Today on Macaulay Math, we're talking types of data. Intro. Okay, good day. I'm Professor Macaulay. This is Math 130, Intro to Statistics, Lesson 2 on types of data. Our goals for today: we are going to distinguish between qualitative data and quantitative data. We're going to classify data with respect to the 4 levels of measurement: nominal, ordinal, interval, and ratio. Statistics is about manipulating data, and there are a lot of different kinds of data. Therefore, it makes sense that we should define the types so that we can determine what we can do with each type. This lesson is very definition heavy, so you may want to get ready to press the pause button regularly so that you can get them in your notes to refer to later. The good news is that this is one of the shorter lessons of the semester. Let's get started.
First off, definition or types of data. We've got qualitative data, and that's going to consist of attributes, labels, or non-numerical entries. Qualitative data consists of numerical measurements or counts. Continuous data can be measured along the real numbers, and discrete data can be measured with integers only.
All right, so there's a nice, easy way to tell the difference between continuous data and discrete data. Continuous data can be divided up and still make sense, whereas discrete data has to have whole number values. Now, a simple example would be the amount of rain we got last rainstorm versus the number of TVs sold at the TV store. The amount of rain that we got in the last rainstorm is going to be continuous data because it makes sense for us to be able to divide that amount up. For example, you can have a half an inch of rain. You can have a quarter inch of rain. The amount of rain can be measured along the real number set. Whereas the number of TVs that you sold has to be measured with integers only. You can sell 2 TVs, you can sell 3 TVs, but it doesn't make sense for us to sell a half of a TV or a quarter of a TV. Therefore, the number of TVs sold is discrete data.
So let's do an example and see if we can figure out what these things are. So first example is freshman class has 142 students. Sophomore class has 152 students. The junior class has 137 students, and the senior class has 129 students. If the following table is formed, which data are qualitative and which data are quantitative? Well, as a solution, the class is qualitative as it labels, L-A-B-E-L, L-A-B-E-L, as it labels the classes, but does not contain numerical data. And number of students is quantitative, Q-U-A-N-T-I-T-A-T-I-V-E, because it contains numerical data. All right, let's move on. Some more definitions. There are 4 levels of measurement. I had to fit it on 2 pages, so that's why there's only 2 here. Nominal level of measurement is qualitative data only. Data at this level are categorized using names, labels, or quantities. No mathematical computations may be made at this level. Ordinal level of measurement, data may be qualitative or quantitative. Data at this level can be arranged in order or ranked, but differences between data entries are not meaningful. Interval level of measurement. This data can be ordered, and meaningful differences between data entries can be calculated. At the interval level, 0 entry simply represents a position on the scale. and the entry is not an inherent zero. The ratio level of measurement, similar to interval level of data, with the added property that zero measurement is inherently zero. A ratio of two data entries can be formed so that one data entry can be meaningfully expressed as a multiple of the other. So really what we got to talk about here is this concept of inherently zero and what that means. So let's go down here. Quantities with positional zero. Temperature has positional zero, and if we're talking, at least if we're talking Celsius, not Fahrenheit, with Celsius, we said the positional zero because zero is when water freezes on Celsius. And but we can have values that are beneath that, minus 10 degrees does still mean something. The second example that I have for positional zero is the year 2019. Year has positional zero. We randomly picked a value, didn't randomly pick one, but we picked one based on a certain concept of what we call year zero, but certainly there was time before that. Quantities with inherent zero, like weight, if you have zero weight, there is no weight there. Monetary value, if you have $0, there is no monetary value. You are broke.
Another way to think of it is, can you divide two pieces of data and have the result make meaningful sense? Let's continue with the money example. Let's say you have $200 and I only have $100. $200 divided by $100 is 2. It makes sense for me to say that you have the ratio of 2 times as much money as I do. Therefore, amount of money has ratio measurement level.
So let's finish off with an example here. Let's name the level of measurement of the following data. So we've got highest grade level completed, we've got gender, we've got year of graduation, and we've got number of years at a job. So first, highest grade level completed. That is going to be ordinal because clearly we can arrange this data in order, but we really can't have a whole lot of differences between those data entries. The second one here, gender, is going to be nominal. And gender just names a person. And but we can't make any calculations based on that, and it is certainly not
Quantitative data because it contains no numbers.
year of graduation. We kind of talked about that before. That is going to be interval because year of graduation doesn't have inherent zero, whereas this last one is going to be ratio because number of years at a job, you can say that I have 0 years at the job, and that's not positional. That actually has a value of 0. And if you were to have like 1 year at the job and your coworker has 5 years at a job, you can say that that person certainly has been there for 5 times as long as you have. So that one was a fairly short one. That's all I got for this particular lesson here. So we are to our Marvel fun fact of the day. Edward Norton played the Hulk in 2008 in The Incredible Hulk, but was replaced by Mark Ruffalo for various reasons in the first Avengers movie, even though they are technically the same character in the Marvel Cinematic Universe. This being the great Edward Norton, and this being the very funny but serviceable Mark Ruffalo. And this was the first Incredible Hulk movie. That's all I got for today, folks. Have a good day. Bye.